Okay, I've got a speaker hooked up to this radio. Right now it's only getting the local station. It's got some distortion. When I touch this, the gain comes up, but it gets more distorted. Now that could be partly because this is not the right output transformer needed for this radio, but it's a start. So I got to find some others. But I'm more concerned right now with this static. That's like DC getting through. And this is the IF amplifier, and it's pulling down that IF can correctly. And this is the mixer, which is mixing in that noise. I'm going to go ahead and do an IF tune on it. It's pretty close. Okay, it's getting that station fine. Could be this antenna trimmer, but somewhere it's getting some static. So before I get in trouble for having that song playing, I'm going to hook up my signal generator and run it through, and we'll do an IF tune. I should already be on the right frequency because I set this up last night. So let's see what happens if we run an IF signal through there. And we'll put it right into the mixer here and connect it to ground. Disconnect the antenna, turn on the generator, modulation full. We should be able to hear that. There it is, nice and loud, no distortion. So I think the distortion is mostly my lights, but I am going to check those resistors anyway. So let's go ahead and tune this IF can, these two IF cans. Now this radio has two IF cans. It has a short can in here. It's about that long. It's like half the size of that IF can. It only comes up, it's about that long, about an inch and a half in here, which you can see through the hole there. The tuning for it is here, but it only has one screw. So it's only got one tuning capacitor. The other one is not, doesn't exist. There is no other one. And it has two on this can. Let's see if I can open the schematic. Here. I'll show you in the schematic what that looks like as soon as my PC opens. We may have to come back to that. I got to get another PC. This thing is slow as dirt. There we go. All right. Get rid of that. And, okay. So here's the schematic. Had to change cameras. And you see, this is the first IF here. That's the first IF. This is the second IF. This is the one that's under the chassis. You see, a regular IF has two tuning capacitors, two slugs in the tuning capacitors. This half of IF can only has one on the output side. The procedure calls for adjusting here. Let's see. Okay, adjust the second IF can first, IF trimmer first, located below the speaker in the front of the chassis, and then adjust the first IF. So you do the second first, which is this one with the one slug, and then you do the two. So we're going to do that. So I'm going to lower the volume so we can barely hear it. And find the screwdriver that I had a second ago. Where did I set it? Hello, where'd you go? How in the world did I disappear? So many tools and so little time. Probably right in front of me. If you see it, speak up. That's just weird. I just had it in my hand. There it is. Okay. Alright, so we're going to do this one first. And get it in there. Okay, we're listening for a louder volume. Right about there. And then we'll do the first IF can. Okay, that's good. See if we can hear it again. Back to the second IF. So it's pretty good. First IF. Okay, so the IF's pretty strong. Of course, this being a 4-tube radio, you know, it doesn't have the reception or the power of an All-American 5 because it's only a 4-tube radio, and it only has a half of an IF can. Instead of 2 IF cans, it's got one, sort of 1.5, kind of think of it that way. So you don't have all of the you just don't have, you know, it's not a high-end radio. It's a battery radio. It's made for running on batteries, and we got it running that way. Okay, and there you see I had the frequency at 455. Okay, well, we ain't gonna be far away at 1400 anyway, which is right about there. So let's see, I'll bring this down to 1400. Okay, 1400. There it is. It's very low. That's it there. Let's see if we can get that up to where it belongs. Should be right there. See if we can find it. This antenna has leaves a lot to be desired. It's almost like this capacitor is not working. Wait a second. You know, sometimes they tell you the wrong thing. Sometimes they tell you to go through a 0.01, a 0.1 nanofarad, and they have it on here. And yeah, I believe that's the case. Let's try it. Just put it right on there. That's just strange. There's the problem. The wire came off, the ground came off. Let's see if I can stick it back in there. Go back to here. And see if we can find it. That's weird. That capacitor is not doing nothing. But on this side, I'm getting a signal. I'm not getting through that capacitor. I can hear it. There's nothing going through that. I think this antenna's got a problem, including this capacitor. Well, look at this. I mean, the wire is holding on by a strand, but that shouldn't be it. This should be giving me this signal. Of course, I can't tune it from this side because it needs to be on the other side of that. I'm going to have to troubleshoot that antenna coil. But the good thing is it's so close to 1400. Look at that. I mean, it's just like a gnat's hair off 1400. So the frequencies are not bad. The other thing I know is that just south of that would be my local station. It's at 1450. So let's see if we can, where it comes in at. Let's take this off. And let's see where it comes in at. There it is there. Again, it's just a little off. It's at about 1475, so it's about 20 kilocycles off. Not far at all. And for this radio, I'd be happy just getting it play louder. and I fine-tuned that a little bit, but we're still off. But we got some problem. Hear the volume? Just me touching it. So there's some problem with this coil. Okay, I'm finishing up on this Crosley and about to put it back in the case. I got it working. And these battery-powered radios, though they're really cool for local stations, they don't have the sensitivity and selectivity that a regular radio has, but they do okay. Let me lower the volume a little bit and get rid of some of the static. I have a lot of interference in this building. I created the power supply for it and assembled it and stained the wood so it would be protected, and got it connected to the radio, and I've replaced the output transformer with a multi-primary transformer, and I figured out which wires supported the speaker. I calculated the impedance of the speaker by measurements of voltage and resistance and all of that good stuff, and found out that it's a 4-ohm speaker. This transformer handles it fine and puts the correct impedance back on the output tube, which is 10,000 ohms. And so we've got the impedance doing fine, and the speaker is now matched to the output tube of the radio, to the output circuit. And I just wanted to do a little demo and show what it's doing. I got it connected to a piece of coax, which is not the best antenna because coax is shielded, which kind of stops the signal. But anyway, I got it connected to it just so I could get some stations, and it'll get local stations without a problem. Battery radios get local stations fine. That's what they were for. They were mostly for rural areas that were not too far from town, but where there was no power to drive a regular radio. And so I'll show you what it does. Now the first station we'll get is bleed over from a high-end station which is right in town. Comes in really loud. It always bleeds to the low end of dials on my AM radios, so just bear in mind, and I'll point it out when we go by it. You won't hear a lot because I don't get a lot down where I'm at. Okay. Okay, that's bleed over from the high-end station. There's a Clarksville station. So that's working. Here's a Cornelia station. Toccoa station coming up right about here. Now again, if I had the correct kind of antenna for this, it would come in a lot better. But it's coming in and it's got volume. It just needs an antenna or wire run. These are designed to have an outside running wire, even though they had a little internal antenna. Okay, then above that, you can hear where it's trying to pull in stations. It just doesn't have the sensitivity. There's one. I don't know if you can hear that, but it's just audio station. You see there's some more. And these would come in with an antenna. They're just not going to come in without an antenna. So that one's there. You hear it's got selectivity, and it tries to pull them in. It just doesn't have the front end it needs. Front end being the antenna. And it's got pretty good selectivity between stations. You see how just a little turn goes by that frequency. Again there. It just can't pull it in because it doesn't have the antenna for it. And I did help that a little bit, which I'll explain in a minute. As you can see, there's things out there, but the radio just can't get to them. It would if it could grab a hold of them, but it just can't grab a hold of them. It knows they're there. Okay, here's my local station. So it gets that one fine, of course, because it's local, it don't need an antenna. All these others would require an antenna. But the radio is tuned, as you can tell. It's hitting things all over the dial. So, okay, that's the radio. The radio is doing fine. It's tuned, it's selective, it's got sensitivity, but it has no incoming signal. There was two problems with this radio that were pretty serious. The first one was, of course, the blown out power transformer, output transformer, which was this one here. And it has an open primary. So, and of course I'll connect this transformer to the same pin so they can be plugged in. But it has an open primary, so it's no good. It's a beefy transformer, but somewhere along the line somebody ran it, with a dead battery or too strong of a battery. I don't know, but somehow or other they burnt out the primary of the transformer. So I'm not able to do anything with that. It had to be replaced. That in itself was a problem because you can't just find these. This is relatively old radio from the 30s, and you're not going to find one like this. So I had to do a lot of research and a lot of searching, and I found this very good transformer. It's by Bojan, which is a major transformer manufacturer, and they do very good. And this transformer has many different taps, and it's they rate them in watts of power capability, and it's a very good transformer. So I was able to find a primary that worked, that the impedance worked. I just taped these off while I was flipping from one to another, but now that I got the right impedance, which is this gray wire and the black wire input, and then the output is these two black wires, which I tacked onto the speaker temporarily, but I'll solder them better. So the gray wire gave me the 10,000 ohms that I needed for this tube's rated impedance. If the ohms was too low, if I used too low of a tap, it would have drawn the current too high and would have burnt this tube out. If I went too high, then we would have lost the gain and the sensitivity that we need, because the amplifier would not have had enough power to actually drive the speaker. The volume would have been considerably lower. Okay, well, we got that worked out. That was a real bear. Of course, building a power supply is a real time-consuming issue, and it's quite expensive, but you got to have it because you got to drive the radio somehow. The other issue is the actual coil, and I've got it hooked up on the ohm meter here, and you see it's about 1.3 ohms. It's a dead short. It's totally shorted, and the wire in it is corroded. You see all that green corrosion. I tried to identify where it's shorted, but I can't. I moved the wires around. It's insulated here, so that I know they're not touching, and I checked that. And I tried to find it, but it's somewhere inside the actual lamination that it's shorted out. It had a lot of damage. This is totally let go here from where it belongs, but I left it off so I could measure the resistance. I had to cut the capacitor out. The capacitor is not doing nothing on this coil. It's actually totally useless because the coil is not working. So I tried and tried to figure out where this short was. I haven't been able to find it. The bucking coil here had a little hair wire that was busted off there. That was a job soldering that back on, but that did not solve the issue. That's just a little a little bucking coil, which is to help get rid of the hum, the 60 hertz hum. Forget it, the hum's gone. There is no 60 hertz hum. There is distortion and, interference from where I'm working, but there's no 60 hertz hum because this is on a transformer. It's totally isolated, so you really don't even need a hum bucking coil. Anyway, but I did something else. I had this antenna. It wouldn't work with that antenna. It'd only get to local station. I couldn't get any other stations at all. Bear in mind, that's the beginning of when they were learning how to make antennas to go inside of radios. At this point, they were still depending on, and that's why you got these long dangling wires here, they were still depending on an outside antenna because it's a DC radio. This would only work if you was in town with it and near a local station. Well, geez, it'd almost work with just bare wires, but it, won't. But what I did have was this 60s model GE antenna that I pulled out of a parts radio. And this is leaps and bounds in technology over this. And you can just see the difference. This is big old thick aluminum wire. This is coated copper, nicely wound. This is a great AM antenna. It still is not sufficient for this radio to get distant stations. You still need an outside antenna. And that would come off of, let's see, the red goes here. Let me shut my meter off. That comes off the white. So that comes off the white lead. Actually, no, I take that back. Comes off it was on the capacitor here to the red lead, which would make sense. Yeah, that's correct, because that's what I'm doing when I plan it. I'm connecting this here. So I will solder this green wire here. The black wire is still here. It's a ground wire. You can connect to a ground. But you don't really need it. What you really need is this wire. This wire needs, it's fine running through this little coil, but it also needs to come from here and run like to a tree or from tree to tree or something like that. You need a very good antenna if you want to get a lot of stations with this radio. It's just not designed for it. It runs on very low power, so low that the tubes don't even light up. You don't even see the filaments lighting up in this. Maybe at night, if you turned all the lights out, you'd see the filaments lighting up. Also, the plate voltages on this is 80 to 90 volts. Actually, I think I'm running around 85 volts. Whereas in a normal radio of this age, the plate voltage would be like 200 volts. Well, obviously, you can't drive a battery radio on 200 volts. There's no 200 volt batteries. So it's designed to run on very low power, which means it needs a very strong signal in order to get a good amplified volume out to the speaker. But you see how even on the local station, when I put it on the local station, you get the volume. Now the antenna is not even connected, my coax. I'm just on this GE antenna. And it's got plenty of volume. If I go above that, you get it right on the station. If I go above that, I'm going to get distortion. That's full volume. I mean, the tubes just are overdriving. They're going into saturation because at 80 volts, that's the most they can drive. But you got plenty of volume on local stations. And that's the way they were designed. I mean, you know, you listen to a comfortable radio, right? You would probably be listening to the news or a talk show back then, and comedy show or something like that. It wasn't designed to rock and roll, you know. It wasn't designed as a teenage bebop dancing radio. It was just designed to give people in rural areas access to news, official information, entertainment through Abbott and Costello and you know, similar broadcasts, Happy Radio Hour and things like that, Comedy Radio Hour. So it's working, it's functioning, the amp's built, the speaker output transformer has been taken care of, the issue there has been replaced. The antenna is now a much better antenna, higher technology, much better. This is, in fact, most of these newer AM radios that use these in the 60s, 50s and 60s, they use these kind of antennas, didn't require an outside antenna. You didn't need a wire, because on the newer radios, the technology is more advanced and the antenna is more advanced, and you're fine. But so it's actually an update or an improvement to this radio to have this modern antenna in there. So I'm going to go ahead and install it back into the case, attach the output coil, power supply directly to the leads here so that it can be directly connected and not have to have a dangling wires like I got here. And then it'll have to stay in the back of the radio, so you know, so that it's safe. You don't want to be touching this. It does have high voltage. And the output transformer, I'll probably just screw it down inside the cabinet next to the speaker, so it will be that way, because there's no way to really attach it to that speaker. I mean, I might be able to bolt it on there. So there you have it. And when I get it back in the case, I'll do a final demo and show you the radio in the case and how it works that way. Okay, this is the Crosley back in its case.
For the last 150 years, as you know,
you can see it's getting some stations. It'll get more. That's the Tacoma station there. A lot of interference here.
Invented a party that
we don't need an antenna, but it's working. There's the local Cornelius station. So, it's working. And I appreciate you watching the video. I'm going to send this back to its owner. Okay, and I wanted to show the inside. This is the power supply, and it's screwed to the deck with two screws, one front, one back. If you found this video interesting, I ask that you give it a thumbs up and subscribe to my channel. I appreciate the support. It helps me keep my channel live. And if you got some comments or questions, please feel free to ask in the comment section below. Thank you. Have a blessed day.